Good morning, dear students. How are you? I hope all of you are fit and fine and doing your study in a well planned manner. In a previous lecture, we have discussed inverse trigonometric function, their domain, their range, and their graph, and the principal value branch. And what is the difference between the reciprocal and the inverse trigonometric function? Sin inverse x and sin x का inverse of sin x and sin inverse x, sin x raised to the power -1 and sin inverse x. What is the difference between these two terms? Sin inverse x, here sin inverse denotes the inverse of the sine function, but in this notation when I write sin x raised to the power -1, it means that 1 upon sin x, which is equal to cosec x. Now in this lecture we will discuss some properties of inverse trigonometric function. In previous classes you have studied some formulae related to circular trigonometric function. Similarly, there are some other formula in inverse trigonometric function. How these formula look like, we will study in this lecture. In a circular trigonometric function, you have studied a formula sine of A is equal to cosec of 1 upon cosec of A. Okay. You have studied this formula. Sine of A is equal to cosec of A. Now, if I study the same formula in inverse trigonometric function, then it looks like sine inverse x sine inverse 1 upon x is equal to cosec inverse x. सी बेटा, जब हम सर्कुलर ट्रिग्नोमेट्रिक फंक्शन में बात करते हैं तो जो फॉर्मूला होता है वो पूरे ट्रिग्नोमेट्रिक फंक्शन पे अप्लाई होता है. साइन ए इज इक्वल टू 1 अपॉन कोसेक ए, पूरा यहाँ पे ट्रिग्नोमेट्रिक फंक्शन आया. लेकिन जब हम सेम फॉर्मूला इनवर्स ट्रिग्नोमेट्रिक फंक्शन में उस फॉर्मूले की बात करते हैं तो वो फॉर्मूला केवल और केवल वेरिएबल पर अप्लाई होता है. सी, ओनली वेरिएबल इज रिवर्स्ड, x and 1 upon x, right? If the same formula is written in circular trigonometric function, then it looks like this: 1 upon sin x equal to cosec x. Right? See the difference between these two formulae. In this formula, the formula applies only in the variable 1 upon x and x, but here the formula applies complete function on complete function 1 upon sin x, here 1 upon x. The difference is that here only x and here sin x, and on the other side it's cosec inverse x and it's cosec x, right? This is the difference between circular trigonometric function and inverse trigonometric function. Difference between the formulae of circular trigonometric function and inverse trigonometric function. Inverse trigonometric function और circular trigonometric function के फॉर्मूलों में क्या डिफरेंस होता है? यही डिफरेंस होता है बेटा. सर्कुलर ट्रिग्नोमेट्रिक फंक्शन में जब भी हम कोई फॉर्मूला लिखते हैं तो वो फॉर्मूला पूरे फंक्शन के साथ लिखा जाता है, लेकिन वही जब सेम फॉर्मूला आप इन्वर्स ट्रिग्नोमेट्रिक फंक्शन में यूज़ करते हो तो वो फॉर्मूला केवल और केवल वेरिएबल पर अप्लाई होता है। ओके, ये जो बात है ये फैक्ट है, ये फैक्ट नहीं, ये एक रफ चीज़ है जिससे आप फॉर्मूले को ईजिली याद कर सकते हो कि आपको फॉर्मूले को याद कैसे करना है। आपको हमेशा याद होता है कि साइन और कोसेक एक दूसरे के उल्टे होते हैं। साइन थीटा इज इक्वल टू 1 अपॉन कोसेक थीटा, कोसेक थीटा इज इक्वल टू 1 अपॉन साइन थीटा। तो आपको इन्वर्स फंक्शन में क्या करना है, अगर साइन इन्वर्स को बेटा कोसेक इन्वर्स में चेंज करना है तो कुछ नहीं करना, आपको केवल जो उसके संग वेरिएबल है उसको चेंज कर देना है। अगर यहाँ पर x है तो यहाँ तो कोसेक में 1 अपॉन एक्स हो जाएगा, साइन में अगर 1 अपॉन एक्स है तो कोसेक में x हो जाएगा, राइट। सी द प्रूफ ऑफ दिस फॉर्मूला, हम इस फॉर्मूले को बेटा प्रूफ कैसे करेंगे। एंड वन थिंग मोर, in inverse trigonometric function all these formulas are valid for some special values of x, not for all values of x. See, in fact they will be valid only for some values of x for which inverse trigonometric functions are defined, but we will not go into the detail of these value of x in the domain। मतलब वो x की किन वैल्यू के लिए ट्रू है या किन वैल्यू के लिए ट्रू नहीं है, हम इस डिटेल को अभी स्टडी नहीं करेंगे बिकॉज दैट स्टडी इज आउट ऑफ योर सिलेबस एज द डिस्कशन गोज बियॉन्ड द स्कोप ऑफ दिस टेक्स्ट बुक। मीन्स दीज फॉर्मूले आर वैलिड फॉर सम स्पेशल वैल्यूज ऑफ x। In circular trigonometric function there is no restriction on x। See, sin a is equal to 1 upon cosec a and it is true for all the real values of a, or I will say all the real values except where cosec of a is equal to 0। If cosec of a is not equal to 0 then it is valid for all the values of a, but this formula sin inverse 1 upon x is equal to cosec inverse x, it is valid for only some values of x। This is also the difference between circular trigonometric function and inverse trigonometric function। Now see the proof of the formula। Suppose we have to prove sin inverse 1 upon x is equal to cosec inverse x। How we will prove this? For this let us consider sin inverse x, sin inverse 1 upon x is equal to y। Okay, now if I will take sin inverse right side then it is equal to 1 upon x is equal to sin y। Okay, if 1 upon x is equal to sin y then we can also write it as x is equal to 1 upon sin y, means x is equal to cosec y, means the value of y is cosec inverse x। Okay, so the value of y is cosec inverse x and the value of y is sin inverse 1 upon x, means sin inverse 1 upon x and the cosec inverse x both are the values of y, so they must be equal, right? Okay, one more time, see, let sin inverse x is equal to y। Okay, now x is equal to sin y। इसमें हमने यहाँ पर हमने कौन सी प्रॉपर्टी यूज़ की, यहाँ पे हमने बेटा ये प्रॉपर्टी यूज़ की, इफ f इनवर्स y इज इक्वल टू x देन y इज इक्वल टू एफ एक्स। डोंट बी कंफ्यूज, ऐसा नहीं है बेटा ये साइन इनवर्स इस साइड गया तो यहाँ पे -1 पावर खत्म हो गई, दिस इज नॉट द पावर, दिस साइन इनवर्स डिनोट द इनवर्स ऑफ साइन फंक्शन, राइट। एंड if inverse image of y is x then y is the f image of x, right? Inverse image of y is equal to x, if under the inverse function the image of y is x then under the original function image of x will be y, this property is used here, right? So x is equal to sin y। Now take the reciprocal of both sides, so 1 upon x is equal to 1 upon sin y, so 1 upon x is equal to cosec y। Now again using the property of inverse function y is equal to what, y is equal to cosec inverse x। आप इसको रफली ऐसे भी देख सकते हो बेटा कि जब कोसेक लेफ्ट साइड में जाएगा तो इनवर्स फंक्शन बन जाएगा, राइट। सो कोसेक इनवर्स x इज इक्वल टू 1 अपॉन x इज इक्वल टू y। नाउ वी हैव टू वैल्यूज ऑफ y, इन इक्वेशन 1 द वैल्यू ऑफ y इज sin इनवर्स x, इन इक्वेशन 2 द वैल्यू ऑफ y इज कोसेक इनवर्स x। Means in equation 1 and 2 right hand sides are same, so left hand sides must be same. So from one left hand side is sine inverse x, and from equation 2 the left hand side is cosec inverse x. So sine inverse x is equal to cosec inverse x. Similarly you can show that cos inverse 1 upon x is equal to sec inverse x, because in circular trigonometric function you have studied cos of b is equal to 1 upon sec of b, right? Now if I will write this formula in inverse trigonometric function, or I can rewrite it as this formula, 1 upon cos of b equal to sec of b, right? So if I will write this formula in inverse trigonometric function, then I have already told you in inverse trigonometric function the formula will apply only in the variable. So cos inverse 1 upon v is equal to sec inverse b, right? Only the variable is reversed. Here 1 upon b, here v, not the complete function. 1 upon cos इनवर्स भी नहीं आएगा बेटा, केवल और केवल वेरिएबल में ये फॉर्मूले चलते हैं आपके. 1 upon b, here 1 upon cos b. So the inverse trigonometric is only 1 upon b and v. See the formula. The formula is what? Cos inverse 1 upon x is equal to sec inverse x. I have used b in place of x. That is a variable, you can use any other symbol, right? Similarly, the third formula is tan inverse 1 upon x is equal to cot inverse x, because you have already studied 1 upon tan theta is equal to cot theta, right? Now the next property is sin inverse minus x is equal to minus sin inverse x. Sin inverse minus x is equal to minus sin inverse x. This is same as sin of minus theta is equal to minus sin theta. And the value of x is what? For which values of x this formula is valid? X belongs to minus 1 to 1. X lies between minus 1 to 1. You have studied the formula sin of minus x is equal to minus sin of x, right? Now when we study this formula in inverse trigonometric function, then this formula becomes sin inverse minus x is equal to minus sin inverse x. Right? Same formula. Sin of minus x is equal to minus sin x. So its form become sin inverse minus x is equal to sin inverse x. This is the formula, right? First property is this, second property is this, and third property is this. I have write both the formula simultaneously so that you can look what the difference between inverse trigonometric function and what is the difference between इन्वर्स ट्रिग्नोमेट्रिक फंक्शन एंड सर्कुलर ट्रिग्नोमेट्रिक फंक्शन। सर्कुलर ट्रिग्नोमेट्रिक फंक्शन और इन्वर्स ट्रिग्नोमेट्रिक फंक्शन में के फॉर्मूले कैसे होते हैं, इन दोनों में क्या डिफरेंस होता है। इससे क्या फ़ायदा होगा, अगर आपको सर्कुलर ट्रिग्नोमेट्रिक फंक्शन के फॉर्मूले याद हैं तो आपको इन्वर्स ट्रिग्नोमेट्रिक फंक्शन के फॉर्मूले याद करने में कोई भी प्रॉब्लम नहीं आएगी, राइट। दिस इज द फर्स्ट फॉर्मूला। I will give the number. Now the next formula is I have changed the color of the formula because for your simplicity. Right? Now see the proof of this formula. Sin inverse minus x is equal to y, so minus of x is equal to sin y. Similarly, using the property of inverse function, minus of x is equal to sin y, so I will rewrite it as x is equal to minus sin y. Okay, so and minus sin theta is also equal to sin of minus sin minus theta, so minus sin y is equal to sin minus y, right. In this way, now again using the property of inverse function, minus y is equal to what, sin inverse x, right. So y is equal to minus sin inverse minus x, so sin inverse minus x is equal to minus sin inverse x. Okay, I will repeat one more time. First of all, let us suppose that sin inverse minus x is equal to y, so minus x becomes sin y by using the properties of inverse function. So whether we should write minus on this side or on this side, no problem. So x is equal to minus sin y and minus sin theta is equal to sin minus theta, so x is equal to sin minus y. Okay, now again using the property of inverse function, sin inverse x, जब साइन यहाँ पे बेटा लेफ्ट साइड में जाएगा तो साइन इनवर्स ऑफ x इज इक्वल टू माइनस वाई, सो y इज इक्वल टू व्हाट, y इज इक्वल टू माइनस साइन इनवर्स x, और आई कैन से दैट मल्टीप्लाइंग बाई -1 both side you will get this equation. Now see the equation number 1 and 2. We have two values of y. Sin inverse minus x is also the value of y and minus sin inverse x is also the value of y. Okay, so from 1 and 2 we will get sin inverse minus x is equal to minus sin inverse x. Similarly, you can show that tan inverse minus x is equal to minus tan inverse x. Cosec inverse minus x is equal to minus cosec inverse x. Now see the next formula. Cos inverse minus x is equal to pi minus cos inverse x. Okay. Now how we will prove this formula? First of all, understand the form of this formula. ये formula इसी form में बेटा क्यों आया? Cos inverse minus x is equal to pi minus cos inverse x. जब sin, tan और cosec में जब हम बात कर रहे थे, when we are dealing with sin, tan and cosec, then simply minus will come out. But when we are talking about cos inverse, sec inverse, cot inverse, तो ये पाई एक्स्ट्रा टर्म कहाँ से आ गई? What is the reason? Okay, so see the reason. You have studied cos of pi minus x is equal to minus cos of x, right? So this is the thing, this is the reason because of which the extra term pi occurs in the formula of inverse trigonometric function. So when I will study this function in inverse trigonometry, then it looks like this: cos inverse cos inverse minus x is equal to pi minus cos inverse x, right? This is the form of this formula. See the similarity of these two formulas. I will provide also this document file in the link in the description of this video. Right, now let us see the proof of this formula: cos inverse minus x is equal to pi minus cos inverse x. Sec inverse minus x is equal to y, so it can also be rewritten as, by the using the property of inverse function, minus x is equal to sec y. So x is equal to minus sec y, no problem. Minus sec y can also be written as sec pi minus y, because sec pi minus y is equal to minus sec y, because we are dealing with second quadrant, and in second quadrant the second function is negative. So sec inverse x is equal to pi minus y is equal to pi minus sec inverse x, right? Sec inverse minus x. Now from 1 and 2, in 1 the value of y is sec inverse minus x, and in equation number 2 the value of y is pi minus sec inverse x, right? So from 1 and 2, what will you get? You will get sec inverse minus x is equal to pi minus sec inverse x. And the proof of first part of the third property is given in the book, so you can see the proof from the book, right? Now see the next property: sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Cosec inverse x plus sec inverse x is also equal to pi by 2, right? Now let us see the proof of this formula. But proof of 1 is given in the book. I am proving the second. Tan inverse x plus cot inverse x is equal to pi by 2. Suppose tan inverse x is equal to y, so x is equal to 10y, right? X is equal to 10 by 10. Now we will introduce cot in our proof. So tan y can be written as cot pi by 2 minus y. Now again using the property of inverse function, it looks like cot inverse x is equal to pi by 2 minus y, and the value of y is what? The value of y is tan inverse x. So substituting this value of y in equation number 2, you will get cot inverse x is equal to pi by 2 minus tan inverse x. When tan inverse x goes to left side, then it becomes positive. So tan inverse x plus cot inverse x is equal to pi by 2. Now how we will learn this formula? Every time you should correlate the formula with formulas of inverse trigonometric function and circular trigonometric फंक्शन. हमेशा बेटा आपको सर्कुलर ट्रिग्नोमेट्रिक फंक्शन और इन्वर्स ट्रिग्नोमेट्रिक फंक्शन को कोरिलेट करना पड़ेगा. इन्वर्स ट्रिग्नोमेट्रिक फंक्शन के किसी भी फॉर्मूले को, किसी भी प्रॉपर्टी को प्रूव करने के लिए फर्स्ट ऑफ ऑल आपको उसे सर्कुलर ट्रिग्नोमेट्रिक फंक्शन में चेंज करना होगा, तभी आप उस फॉर्मूले को प्रूव कर सकते हो. दिस इज द की पॉइंट. For proving the formula of inverse trigonometric function, we have to change them in circular trigonometric function, because we are familiar with the circular trigonometric function, not with inverse trigonometric function, right? So see how will we learn this formula. See, you have studied tan of x tan x is equal to cot pi upon 2 minus x, right? Tan x is equal to cot pi by 2 minus x. So in inverse trigonometric function it is equal to tan inverse x tan inverse x tan inverse x equal to pi by 2 minus cot inverse x, right? Now see the next formula, next property of inverse trigonometric function. In circular trigonometric function you have studied a formula tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b, or tan a minus b is equal to tan a minus tan b upon 1 plus tan a into tan b. Now the next formula is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So let us see. You have studied the formula tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. Then if we will talk about the inverse trigonometric function, this formula applies only in variables. See here, this is tan a plus tan b, here only a plus b. Here 1 minus tan a into tan b, here only 1 minus ab. Similar formula as circular trigonometric function. The difference is that in inverse trigonometric function formula applies only in variables. Tan a minus b is equal to tan a minus tan b, tan a minus tan b, and in inverse trigonometric function a minus b. In circular trigonometric function 1 plus tan a into tan b. In inverse trigonometric function it is 1 plus ab. Now let us see the proof of this formula. For this, first of all change these two functions in circular. So let us suppose that tan inverse x is equal to a and tan inverse y is equal to v. Then by using the property of inverse function x is equal to tan a, y is equal to tan b, you have to prove the formula for a minus b. Okay, so apply the formula for circular trigonometric function tan a minus v is equal to tan a minus tan b upon 1 plus tan a into tan b. Simply substitute the value of tan a and tan b. The value of tan a is x and the value of tan b is y. So it is equal to x minus y upon 1 plus xy. Again using the property of inverse function, a minus b is equal to tan inverse x minus y upon 1 plus xy, right? So and the value of a minus b is what? The value of a minus b is tan inverse x minus tan inverse y. So tan inverse minus tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. Similarly, you can prove this formula for positive sign, and the proof for the positive sign is given in your book. Proof of the first part is given in your book and proof of the second part is given in my solutions, right? Now see the proof of the third part. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. You have studied the formula of tan 2 theta. Tan 2 theta का formula बेटा क्या होता है? The formula of tan 2a is 2 tan a upon 1 minus tan square a. Now when we use this formula in the inverse trigonometric function, then it looks like this. 2 tan inverse a is equal to tan inverse 2a upon 1 minus a square. In place of tan a, it is equal to a, and in place of tan square a, it is equal to a square. This is the way how we will learn the formula of inverse trigonometric function with the help of circular trigonometric function. Now see the proof of this formula. For this formula, tan inverse x is equal to y. Let us suppose that. So x is equal to 10 by the property of inverse function. Your LHS will be what? Your LHS will 2 tan inverse x, and the value of tan inverse x is y. So it is equal to 2y. Now RHS. Tan inverse 2x upon 1 minus x square. Put the value of x is equal to 10 by. Now this is the formula of tan 2y, and by the property of inverse function, tan inverse and tan becomes identity function, so it is equal to 2y, and 2y is also equal to LHS. So the value of LHS and RHS will be same. In this way you can prove the formula 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Now see some more properties. Property number 6. 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. These two formula. Right. Now what is the connection between this formula and the formula in the circular trigonometric function? Let us see. In circular trigonometric function, you have studied this formula 1 minus tan square a upon 1 plus tan square a is equal to cos 2a. Now this formula becomes cos inverse 1 minus x square upon 1 plus x square. In place of tan square, it is equal to x square. See, x square. And cos 2a means this 2. So here this is 2, and we are dealing with the inverse function, so it is equal to tan inverse x. Similarly, in other formula, you have studied one formula 2 tan a upon 1 plus tan square a is equal to sin 2a. Then it looks like sin inverse 2x. See, 2 tan a means 2x. In place of tan a is equal to only x, and 1 plus x square. Here not minus. Here this will be plus, right? So sin inverse 2x upon 1 plus x square is equal to 2 tan inverse x. Now let us see the proof of these two formulae. 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. First of all, let us suppose that tan inverse x is equal to phi. So by the property of inverse function, x is equal to tan phi. Now put the value of x, cos inverse 1 minus x square 1 plus x square, so 1 minus tan square phi 1 plus tan square phi. Now when we simplify it, after changing in sin and cos, you will get cos 2 phi. So cos inverse cos 2 phi, by using the property of inverse function, you will get 2 phi, and the value of phi is what? The value of phi is tan inverse x. So it is equal to 2 tan inverse x. This is the result which you have to prove. Now see the second formula. Sin inverse 2x upon 1 plus x square is equal to 2 tan inverse x. So for this, let us suppose that tan inverse x is equal to theta. So x is equal to tan theta. Simply put the value of x, 2 tan theta upon 1 plus tan square theta. Now change it into sin and cos, and you will get sin inverse sin 2 theta. It is equal to 2 theta, and the value of theta is what? Tan inverse x. So sin inverse 2x upon 1 plus x square is equal to 2 tan inverse x. In this way, I have told you the proof of some properties of inverse trigonometric function and what is the similarity between circular trigonometric function and inverse trigonometric function. How these formulae are correlated to each other. Okay. And by correlating the formulae of inverse trigonometric function and circular trigonometric function, it is easy to learn these formulae. Otherwise, you cannot learn it, right? Okay, thanks for watching this video. If you have any query, any doubt related to this video, you can tell me in the comment section. Have a good day. Thank you.